All right, so last time we figured out how to calculate the degrees of unsaturation with just carbon and hydrogen compounds. But what if you have heteroatoms in there? How does that change up the game? So let's think about it a little bit. So first off, we've got halogens. And so if we think about propane, this has 8 hydrogens. And then what if we substitute one of these hydrogens with a halogen? Now we're with one less hydrogen, right? This only has 7 H's, and so halogens will reduce the number of hydrogens expected. Next up, what if we have an oxygen? Right, so again, our analogy of our propane here. We have 8 H's over here. And then if we switch this off with an O, oxygen forms 2 bonds. And so we have this H here as well. And so this also has 8 H's. And so you can see because oxygen forms 2 bonds, there's actually no effect on the number of hydrogens expected. If it has a double bond, then that's a degree of unsaturation, not just because of the oxygen. Next up, we have nitrogens. So again, our our propane example, we have 8 hydrogens here. If we replace one of the hydrogens with a nitrogen, now we have an NH2 because nitrogen forms 2 bonds or 3 bonds. And so here we have 9 H's. And so you can see the overall effect is 1 extra H than what we would expect. And so if you combo all of these things, you get an equation, right? So your degrees of unsaturation or your hydrogen deficiency index, whichever way you can think about it, whichever way you want to think about it, is going to be equal to 1/2 times 2 times the number of carbons plus 2 plus the number of nitrogens minus the number of hydrogens minus the number of halogens, right? Oxygens aren't involved, so they're not necessary, right? And so once you calculate through, this will tell you how many degrees of unsaturation you have. So for example, if we have a molecular compound that's C4H8ClNO2, we can plug that into this equation, right? So our degrees of unsaturation will be equal to 1/2 times 2 times the number of carbons, which in this case is 4, plus 2, plus the number of nitrogens, which in this case is 1, minus the number of hydrogens, which in this case is 8, and then minus the number of halogens, which in this case is 1. And then if you plug and chug through the math there, you will get 1. So you have 1 degree of unsaturation. And so you can draw different constitutional isomers of this compound that have 1 degree of unsaturation that may provide you hints of what's to come, right? So you're going to have 1 pi bond or 1 ring. Those are pretty much your only options. And so which compound it is, the mass spec alone is not going to be able to tell you. And so you can draw a whole bunch of different isomers that'll fit into this criteria. If you're asking yourself which one is it, we have to then use IR or NMR to help us out further.